Homework 8, Inverse Functions, Video 3. In the last video, we showed that two functions were inverses because I asked you to show that they were inverses. But now I'm going to pose the question a little more open-endedly. Are these functions inverses? The first function is x squared. What would you think its inverse would be? What function do you think would unsquare something? Wait, we've unsquared things before by square rooting them. So we're going to answer the question in our f of x equals x squared and g of x equals the square root of x inverses by going through the same form motions. F of g of x equals f of g of x, replace the inside function, f of the square root of x. We're going to square the square root of x. The square and the square root cancel. Everything looks good. Let's try it the other way. G of f of x equals x squared. G of f of x equals g of f of x. Replace the inside function, g of x squared. The g function says square root, so I'm going to square root the x squared. And those seem to cancel. So everything looks good. However, there's a problem. You may not see it yet. We have to check the domain. Let's just write capital D subscript f equals capital R subscript g to say domain of f equals range of g. And capital D subscript g equals capital R subscript f. And ask the question, is the domain of g equal to the range of f? We can do the same thing we did on the previous problem. We can look at these graphs to see what their domains and ranges are. Let's assume that we already know what the graphs look like. After all, we have talked about these before. F of x equals x squared is this parabola, whose vertex is at the origin. G of x equals the square root of x is the top half of a parabola opening to the right. Based on this parabola, what is the domain of f? Well, it goes forever left and right, so it's negative infinity to infinity. Based on this parabola, what's the range of f? Hint, it's not negative infinity to infinity. It's bottom to top. This parabola bottoms out at 0 and includes it, so it's a bracket on the 0 and goes up forever. So bracket 0 to infinity. But what about the g function? What is the domain of g? Well, domain is left to right, and from left to right, this goes from 0 to infinity with a bracket. Good. That was supposed to match. The domain of g matched the range of f, so this fourth condition is a yes, but it's about to fall apart. Because what's the range on the second function? Range is bottom to top. Bottom to top is 0, and it goes up slowly forever, so the range is 0 to infinity. Well, we needed the domain of the first function to match the range of the second function, and it didn't. No. So it's that one thing that makes the answer to the question no. F of x equals x squared, and g of x equals the square root of x are not inverses. It looks like they ought to, but they can't be. And here's the reason they can't be. The square root function can only give back one value, a positive value. Now if you're thinking, wait a minute, didn't we put a plus minus in front of square roots before? Well, yes, but the time to use a plus minus in front of a square root is when you have an equation that you're solving, and then you put a square root on both sides. We're not solving anything here. We didn't just drop a square root on both sides of something. It was just part of this function. When you square root a number, and that's all you're doing, it always comes out positive. So, let's give it a test run. Give me a number. 5, okay. Square the 5, what do you get? 25. Square root 25, you get the 5 back. Give me another number. -3, okay. Square -3 and you get 9, but when you square root 9, you get 3. 3, not negative 3, not plus minus 3, 3. Ask your calculator. Square root of 9 is just 3. There's a number I can start with that I can't get back. If I start with negative 3 and square it, and square root that answer, I won't get negative 3 back. That's why they're not inverse functions. You always have to be able to get back what you started with. So this kind of shows why the domain range thing is necessary. There's no way I can get back a negative 3 that I put here into the F, because there's no way a negative 3 is coming out of the G. Negatives don't come out of the G, only positives come out of the G. So the whole domain range thing is kind of important. But this kind of raises another question. How can you tell in advance that a function won't have an inverse? Because if I knew that this wouldn't have an inverse, I wouldn't even bother checking. And there is a way to check, and I'll give you a hint. It has to do with this graph. Actually, it has to do with both of these graphs.